into the. Joe's been around a while. He got his BS in Forest Resource Management from Southern Illinois University in 1977 and began working for the Forest Service that same year. Eventually, he ended up in California on the Stanislaus, and he is currently the Forest Service Regional Silviculturist, and one of his several responsibilities is the program manager for reforestation. So those of you who knew Mike Landrum, Joe is the next iteration of Mike Landrum. Not to slight Mike or Joe in saying that. Okay, so thanks a lot, Joe. There you go. It's all yours.
Thank you very much. I wasn't quite sure how to interpret that last part. Okay, so what I will talk about, of course, will be National Forest System reforestation efforts. And what I'd like to do first is to talk about what I think of as the backbone for why the Forest Service regards reforestation as important. And I will explain some of the ways that it's expressed to us in terms of guidance and direction first. And then after that, I'd like to follow along in a kind of stereotypical reforestation process way and describe to you what we've been doing, the problems that we're having, and the thoughts that we're having about for the future to try to make things work, be more effective, and also to be effective in the long term. So let's see if my display is delayed a little bit. Okay, no delay at all for me anyway. Okay, so the first part, believe it or not, the agency actually has a mission statement, and there's parts in the mission statement that I think are very important to that relate to reforestation. And I think maybe you've seen some of these type of things before. You know, this idea that we are maintaining the health and diversity and productivity of forests. And the part I like personally about this and other statements is I like this business of being related to both present and future generations. And I think reforestation is an excellent example of how we pay attention to both today and tomorrow. So underneath the mission statement, the portion that I've captured here, there's other important words and phrases that are there as well, and talks about achieving quality land management, and they're talking about sustainable multiple use management to meet the diverse needs of people and society over time. So these are important concepts that the agency has adopted and incorporated into a mission statement. And as you'd expect as a federal agency, we have a legal foundation as well. So the Forest and Rangeland Renewable Resource Planning Act was later amended by the National Forest Management Act. And there's portions in there where they specifically talk about reforestation. And this is the part where, well, I can remind you of something I believe you've heard before, and that is, this phrase, the phrase is about the policy of the Congress, that all forested lands in the National Forest System shall be maintained in appropriate forest cover, species of trees, degree of stocking, rate of growth, and condition to secure the maximum benefits of multiple use, sustained yield management. And the last part of this, and that's the real key part, is in accordance with the land management plans. And in an unfortunate way, many of our plans do not address directly reforestation. It's addressed, in a sense, indirectly by you need to have reforestation occur and be successful in order to meet the long-term needs of the National Forest, the full set of National Forest objectives for the whole set of resources that we typically try to incorporate into our actions. Then we slip into the world of the Forest Service Manual, which of course all of the agency employees know by heart. One of the relatively newer ones, a newer section, is this Chapter 2020, where we talk about ecological restoration and resilience. And this is a pretty important addition, and it's meant really to bring new information and a new theme to the way that national forest management occurs. And you'll recognize those three terms at the bottom as sustainability, resilience, and restoration. They've all been defined in this chapter, and they've been and they've used the widely accepted definitions of these terms so that we can speak in a way with our collaborators, anybody that wants to get involved with us, in ways that are understood across any type of background that people might have. So this was an important thing for us to do, and it's still really, well, it's really in its infancy. The full text of the chapter has not been written, so this is an area where it probably takes another 2 or 3 years for us to try to have something that's really more fulfilled in terms of what's really meant by all of these phrases. This type of manual is something that's been around for a long time, the silvicultural practices portion of it. And this is where a lot of us have come to understand the real core activities that are expected of us. So there's a portion where it's talking about silvicultural practices, and another portion that's talking about forestry improvement. It brings in the genetic resources that are important to us. So with regard to the reforestation part, within silvicultural practices, this is another place where the term appropriate forest cover is brought in, talks about an objective of making sure that we've improved the quality and yield of forest stands. And that's a direct linkage to our recognition of our role as providing for some level of timber production on national forest system lands. That's not as easily understood or recognized by a lot of people in the more modern era, but it still is an important part of a national forest system management. Some of the things that John talked about earlier are carried forward. For example, they talk about cost efficiency, appropriate stocking levels, and timing of when things are expected. These are all objectives that need to be better displayed in our newer plans. So as we go from old plans to the revised plans that we're just starting to work on, we would expect to have more information about what this really means, so that we understand whether we're being successful or not as we move forward. If we talk a little bit about the genetics part, the forestry, the label is forestry improvement, but we commonly refer to as genetic resources now. This is an area that's really been under development for many, many years, and I'll talk about that a little bit later as well. So the direction was to make sure that we base reforestation treatments to make sure that we have site-specific resource requirements, and there's a tie-in there to the genetic resources. So the objective is to use genetically improved seed and planting stock, making sure that we have full awareness of what we're trying to do with this particular planting stock. I'll talk later about another item that John mentioned earlier, is what makes sense today. The seed zones of the past, the breeding zones that have been designed, and how they will help us meet future generations' needs as we move through the decades, and we learn more of just how quickly the effects of climate change will impact our forests. Within the genetic resources management portion specifically, there's a lot of talk about well-adapted plant materials, the restoration of sites that have been disturbed by disturbances like fire, the ideas that we know something now and we'll know more later about how to make sure that the planting stock that we use today is tailored to meet the demands of our future decades and centuries. Because of course we are talking about trees that can last for centuries. And then something that's very recent in our particular region itself is this leadership intent. It took a long time for the folks to build this document, and it's a few pages of carefully worded phrases and claims about what we want to do. The things that I think are important to mention today is that the leadership intent is, there's an intent to do something. There's an intent to make things actually happen, to not sit around and watch things go by without us not trying to make things work. There's also this goal to make sure that we enhance various resources. Some of them specifically stated are the ecosystem services, which include, of course, a variety of things: carbon, wood products for people, wildlife habitat, clean water. The list is long, and I think you've seen lists like this before. And also, an emphasis continues on maintaining some awareness and linkage to the important communities that our forests are located in, to make sure that they benefit as well to the work that we do to try to restore landscapes. Okay, so the needs that exist on national forest lands are primarily related to wildfire these days. There still is a portion of our work that's related to small group selections and reforestation of gaps that we purposely create. But the largest extent of the work that we do is related to wildfires. And this is something that's the acreage that's accumulating year after year is significant, and our efforts continue year after year to try to rebuild forest after changes like this have occurred. So I'd like to show some things to you about the efforts that we use initially to assess how much of change has happened with wildfires, and the tools that we use to try to respond to them. Okay, so this is a standard product that's produced for us. It's called this is the Ravage project. That's an acronym. Where would we be without more acronyms? This is Rapid Assessment of Vegetation Condition After Wildfire. And what you see here is a gradient of change, the red being the most significant change, and the green being the least or minimal change. And the areas that are coded in the red color in this map, this is the American fire on the Tahoe. That red color represents an area that, and this is through satellite data, where a range between 75 and 100% of the existing basal area pre-fire has been lost. So this tells people graphically, visually, that this is the extent of significant loss of forest cover. And so most of the trees that are within those red areas have died with the fire. Now, there's one thing that I'll talk later about too. If you look at this map, you'll see that there are large patches and there are very small patches. So when ranger district staff are presented with this, they get to make some choices. They get to make sure that they see these places in the woods, not just stare at computer screens, and visualize where are the important places to respond to. So certainly the larger places are an area of focus, but an awful lot of the smaller patches that are embedded in a relatively intact forest become less and less important to us as we focus more and more on these larger patches. So one thing to make note about this, so there's this map that's produced nationally, out of a nationally based organization for us, and it uses these 4 classes. And the high severity class is the one that shows in red here. It's part of a 4-class system, but we've tried to take it a little bit further in this particular region, and we've changed. Again, these are continuous variables where high severity on one end and no effect or very little effect on the other end. So this is a graph. This is a screen capture of a spreadsheet. This is the product of something that we do in this region. And I'd like to point out how this is used by us. So again, I have stayed with the American fire. And if you'll notice that there are the 3 categories, the 3 broad categories of treatments not permitted, treatments permitted, and then a second treatments permitted based on steep or flat ground slope classifications. And then over on the side, on the vegetation types, you could see the ones that have been accumulated some acres in there. So to be very specific about this one, if you look at the pine types row, and you move over to the treatments permitted on steep ground, you see that approximately 308 acres have been classified as deforested. Moving over another couple of columns to the right, you get the deforested forest land on flat ground, and you see the slope classifications at 30%. So these 2 acreage values are places that we ask ranger district staff to look at and evaluate and look to see if there's a reforestation need to respond to on those places. We expect that these grand totals would be somewhat less. especially because of the reason I described earlier on the previous slide, where those tiny openings within an embedded green forest, they probably don't need our attention certainly as much as these larger patches do. I should mention something about this term deforested condition. So I don't know. Actually, originally I was a little uncomfortable about that term, but we talked a lot about it with a variety of people, and we couldn't really come up with something that sounded better or meant or communicated more of what was meant to be communicated. It's really a place where, with somebody on the ground would look at and say that basically most of the trees have died, and we've changed a forested condition to a non-forested condition, at least for the moment. The type of work that you see on this particular slide with these acreage figures, this is the result of a 7-class system, and it's the result of Mike Landrum, Dwayne Nelson, and I walking around in a variety of fires and looking at and examining each of these classes, these severity classes, and making some visual assessment of whether or not reforestation would be a reasonable response to this condition. So this one is the real acres. If you look at the acreage associated with the previous one, it's a little bit less than these would be. So if I can just, I'll go back for 1 second. You'll notice the yellow category. So portions of that yellow category we'd probably grab some of them. It was a difficult choice to make on that particular classification because it varied quite a bit. But we wanted to make sure that people had a chance to see on a map where to go and what to look for. Here's an example of small groups that were created on the Lhasa National Forest. Just wanted to make sure that people remember that we still do these things. These were created in response to the expectations of the Quincy Library, the Erger-Feinstein Quincy Library Group Act, and those places may or may not be planted. A lot of the decisions about how reforestation occurs within these groups are based on the presence of a more desirable species. Maybe ponderosa pine, maybe Jeffrey, maybe sugar pine, and if that's not present, or people just want to ensure that things work the way that they want them to, then planting of primarily ponderosa pine, Jeffrey, or sugar pine are the dominant reactions to these type of openings as well. Now, these small groups are created in other places as well. That's not just what was the Quincy Library Group effort. Other forests use groups like this to increase the amount of ponderosa pine, Jeffrey pine, and sugar pine on the landscape, and especially in places where over the decades, and primarily due to early 20th century harvesting, a lot of the pine were removed and a lot of white fir had become dominant in places where it's been felt that pine was much more dominant than it is now. So these are reactions and responses to that species composition shift that a lot of people have noticed over time. I wanted to show you some of the acreage extent of what's been going on. So thinking about that ravage map or that spreadsheet screen capture that I showed you, that's what you see on these big solid bars. And what you see in the multiple colors within the bar represent different forest types, and you can see them, I hope you can see them well, on the bottom of the slide. So you look at these big numbers, 65,000 acres in 2008, and then the changing numbers of years over time. This particular, not now that we're in the new year, last year, the forest of 2013 added up to a little around, close to 60,000 acres. So these, and I only took a look at the last 6 acres, the last 6 years, because I wanted to make sure that we stayed relatively current here. The other 2 lines that are shown are what we've done so far. You'll notice the blue line and how it peaks in 2010. The reason that it peaked in 2010 is primarily because it was a response to the 2008 fires. Most of the responses that we have to 2008 fires will start in 2010. and continue in 2011 and after, as long as we want to keep moving forward and reestablishing forests. That second line below, the kind of an orangish colored line, that one represents certification of natural regeneration. Those are places where the natural regeneration has done the job for us in terms of species composition and distribution over the site, so that we could regard those as satisfactorily stocked and in a condition that we want to move forward with them without adding additional trees. You could see, however, though, that the numbers of acres that are added every year are pretty significant, and the difficulty that we're having in trying to get more and more acreages added to the planting or to certification of natural regeneration columns. Okay. Talking about site preparation, this has been a very difficult part of this process, especially related to the places that have been affected by wildfire. Fire salvage on the national forests is complicated and controversial. That probably is understating it quite a bit. We've always managed to include snags after wildfire. And then one of the primary reasons was the relationship between those snags and beneficial aspects of wildlife habitat. We've also been doing it for soil productivity viewpoints as well. In any event, it takes time. It's not easy to get through the analysis and decision-making process because not everybody thinks it's a fine idea. Some other delays may occur. But we're continuing, I think most of you that are involved with National Forest System Management understand one of our big C words now is collaboration. And so that a lot of these folks that are interested in what we do are invited to the table early, and we have a chance to try to work out some strategies that'll keep people happier than they perhaps have been in the past. In any event, though, as it affects site preparation, can you imagine some of these stands with, many hundreds of trees that are now standing dead, and how to reestablish within an environment like that? Should it be salvaged? Should it not? Are we going to be able to move fast enough so that the trees still have value so that we can actually have somebody remove them for us without needing to pay for the removal or treatment of them? And then which part of the fire, is suitable for salvage? Where can this work actually occur? So we're confronted with an awful lot of dead standing trees and trees that are starting to fall down in a lot of our reforestation projects. Adding to that is the management of competing vegetation. John mentioned some things that are germane to this earlier. The practices that we've been using so far actually include nothing, where we believe that the fire is still not, the vegetation after the fire is still not rebounding as quickly as would make it more difficult. We also have some mechanical, and we have herbicide applications that are not commonly used, at least at the moment, not used for site preparation, but later on. One other thing that's been used, and I'll show you this here in a second, is you're familiar with, a common practice, of course, is to scalp a planting site. And so now what we've done to try to provide site preparation in a sense at the time of planting is to scalp not only the planting spot but also a planting a radius around the tree. And so that's what you see in this particular graph with the green. The green bars, they represent primarily the scalping efforts that people are using to try to enhance the survival of these planted trees. It's something else to add to this. What I've added to this slide is the planting with the line. But what goes on here is, of course, now the planting the green that's occurring as scalping. That's the time of planting. So that's the same year. The purplish colored bars, the portion of those bars, they are occurring, as you'd expect, they're occurring earlier in an earlier year. I want to point something out to you too. So if you look at the legend, you notice there's actually a category for burning, and so there are places where they've tried to reduce surface fuels and the dead trees again, but you can see visually you can't even see the acres, so it's a very small amount that's done. That's primarily because people regard the site as relatively sensitive at this point in time, and so doing something like removing additional ground cover isn't very well, it's not valued by an awful lot of people. Many of you maybe perhaps have been around the block a couple times as well. You might recognize that first the publication on the left-hand side. That's an interesting publication that came up a long time ago, and it's this is a 1984 publication, and within it though, so in 1984, Ron Stewart, a former regional forester here, and others built this document, and it has abstracts for 260 publications to describe the effect of competing vegetation on forest trees. So the agency knows quite a bit, and we've known quite a bit for many years. Adding to that, a relatively recent publication by Phil McDonald and Gary Fiddler, and I think most of you probably know those two folks. Now Phil is retired, but one of the products that he's helped create with Gary has been this publication. Imagine this. This is a pretty significant document, and it provides a lot of information about the results of a variety of treatments of competing vegetation in planted forests. It's something that I think that all of us that are involved with reforestation should have read and tried to soak up the knowledge that's been gained over these 25 years. It was a very important effort. It's California's version, the Forest Service version in this region of a national administrative study designed to try to make sure that we knew what we were doing and what type of trade-offs existed between a whole variety of treatment methods, whether it by scraping vegetation off, using animals to browse, to remove vegetation, fire, mechanical methods, and herbicides. We're all part of this really significant document, and it's a great source for information. Okay, I'm going to focus on this now. This is something that's really a concern for us, but it has a great ending, or at least we're not done. It has a great story to tell. So many years ago, in the mid-'70s, there was a desire to build a plan on how to improve forest trees for future generations, and so those efforts that started in the mid-'70s are now yielding seed from improved seed from trees in our seed orchards, and it's a really valuable story to hear and understand that we're finally gaining these products that took decades to produce. So it really is a great success story, and it is part of our reforestation program to use seed from seed orchards. We still are collecting seed though from trees every year, and the genetics resource staff are building strategies and plans with the forest to determine how much seed do we need at certain elevations, and which species are we most interested in, so that we have stuff that's in the bank, in the freezers, as well as stuff that's growing in the orchards that we could rely upon after events like this year. The rimfire added an awful lot to the deforested condition this particular year. And so being able to rely upon the seed that we have in the bank and the seed that can be produced in our seed orchards is really, really important to us. Another part of this program, though, is the rust-resistant sugar pine program. Those are sugar pine, by the way. Years and years of work have been going on, and we now have rust-resistant sugar pine in the bank that people are using to as part of the reforestation program. We also have an awful lot of seed from sugar pine seed that hasn't been tested that we can still use, and so it's really a pretty good story to talk about seed and seedlings in this part of in this region. We've got a lot to do, and we want to keep doing it because we haven't got every single need met. But there's some great work being done. Tom Blush, our regional geneticist, has done a great job following in some of the pathways of our previous geneticist Jake Hitzmiller, and the folks that work with Tom are doing a great job making some of this happen for us and supporting reforestation. Joan Dunlap, the program manager for the sugar pine effort. This is great stuff going on, and thankfully we could rely on these people and the products to make these things work. One quick mention also, people have been concerned about the genetic variability, the broadness of genetic variation that exists within our seed that we're storing and using. And in addition to the foundations that Jake Hitzmiller developed, we're also taking advantage of the National Forest Genetics Laboratory work, Valerie Hipkin being the director there, to take a second or even a third look at the genetic resources that exist within our seed and within our forest stands to make sure that we're addressing the genetic concerns appropriately. By the way, I mentioned I took a look at a rough calculation of how much seed we had on the Stanislaus, and in particular for ponderosa pine. And while the forest hasn't submitted a sowing order yet for anything, they're still trying to make sense of what to do with salvage options. We've got a fair amount of seed, especially ponderosa pine, for example, at these elevations. So we might be okay. We hope to be. We're going to design to be okay to provide seed for that forest as the years go on, including any collections we'll make this fall that we can keep adding to the mix. Okay, I talked a little bit about this before, and John mentioned a little bit. So Mike Landrum, and maybe this is a lesson for any of you that are thinking about retiring. In the last couple of years that he was with us here, he got really interested in two things. One, ArcGIS. He became quite the master of playing with software that he hadn't had a chance to play with before. And then he was also interested very much in climate change and what it would mean as climate's changed and the impacts, the environmental forces that will be expressed on a tree, let's say at 4,000 feet, are probably going to be different in a decade or two or three. And some of those maps that people produce watching forest types migrate up the hill, up in elevation, they're not really encouraging. I'm actually a fan of global cooling, so I'm hoping that we can make some of that happen. Anyway, what I wanted to talk to you about here is this little graph I'll show you on the next slide in a bigger format so you can see. So there's two things that have gone on. One, we thought a great deal about how to make better choices about going from the source of the seed to specific planting sites. And then also to some adaptive monitoring plots. They're small acreages, but they're on several national forests here. And the idea was to put a variety of different sources into a particular spot in a unique planting site to see how they're going to respond over time, and leaving just enough record so that the people that will be working on the forest in the decades to follow will be able to make some sense of what's happened and whether or not these decisions were worth making. On this next slide, but the part I want you to look at here on this next one is, if you'll notice the X and the cross and the round dot, those are the places, those are the sites that were planted. And notice the axis. On the y-axis, it's mean annual precipitation, and on the x-axis is the mean annual temperature. So those funny-looking polygons that you see there, they all represent a seed zone and an elevation band. So what Mike did was he plotted all of those, anything that was in a certain seed zone and a certain elevation band, he captured all of the mean annual temperature and precip data and plotted them on a graph like this. And then he drew a line around the boundaries of the apparent boundaries of those different values. So that's what they represent. So for example, with the first one that you can see, the incense cedar, that line that follows around that goes up and around and creates that polygon, that all represents seed zone 301 and an elevation band of 1,000 to 1,500 feet. What I thought was interesting when he was doing this is look at the temperature variation and precipitation variation that exists within that zone. And I think that really says something to work that's going on now, and Tom Blush has shared information with me about how we're starting to take a look not so much at specific elevation zones per se by, for all the species, but rather site-specific, or rather species-specific zones. And that might make a lot of difference in terms of how successful we'll be in future plantings. Okay, so now let's talk about making these things work. And this is an area that I think has a lot of people. I'm pretty concerned about some of this, and a lot of people are drawing some conclusions about some recent research. So I'd like to talk a little bit about this. So most of you have seen square or rectangular spacing. I think you know that whatever the number of feet might be, or meters, however people wanted to do it, that's been going on for a long time. And many of us have walked in planted forests where you can still see a representation. You can still interpret how they did make sense of a square or a rectangular spacing. In the recent years, there's been discussion of this clustered planting strategy. A clustered planting strategy is different. It still can be, cluster centers can still be on a systematic pattern, a systematic grid of sorts, but they're further apart, typically, and they have more than one tree planted around that point of the cluster, so that there might be, if I was to guess, and I've never asked everybody, but if I was to guess, the most common approach that's used in this region by those who do use it, and it's not used universally, are three trees. And the three trees are placed a designed distance apart from each other, creating a triangle. And so the goal of clustered planting is to provide for better conditions if, one of the considerations, provide for better conditions if you aren't able to thin later. It also provides for the survival of at least one tree in this cluster. Otherwise, if you can imagine, if you only planted one tree on very wide spacing and the tree dies, then you haven't, unless that's what you wanted to do, which seems hard to think of when you've got all this time and energy and human effort involved in planting a tree. You don't want that to happen. So it's a little bit of insurance as well. You can mix species within the cluster. You can thin them if you wanted to, pre-commercially thin, or not. Or you could just leave them. A whole bunch of interpretations have been made about how to use clustered planting. And there's nothing inherently wrong with using clustered planting, but it is something that's been, I think it's worth talking about more. And this founder stand, so if you can imagine back to that map of the American Fire, and I know you couldn't see the topography there, but if you're in some deep canyon and you've got benches in the canyon slope that were well forested, and maybe you want to make sure that there's still some forest down there for the future, or places that are really difficult to get to, you might use a founder stand to ensure that there's a future forest in the area. And these founder stands are relatively small in size, maybe something like an acre, but they're places where people place a lot of energy and effort to make sure that the trees survive, that they thrive, and that they'll make it to be sexually mature and provide an opportunity to distribute seed over the area that they can influence. Okay, just to clarify, so this is what the square rectangular spacing is something I'm sure you've all seen, and of course it's way too simplified here. Nobody has the ability to plant like that except maybe by machine, or people that are really, really concerned about getting everything just right. So nothing is ever really square, nothing's ever really rectangular. And then the clusters might look something like I've illustrated on the right-hand side of this, where 3 or more trees can exist in a cluster with the central point of a cluster being distributed over the acreage. I wanted to bring this up too because it has a lot to do with, okay, we've got a planting pattern, but we don't know how many trees we want to establish out there. So this is from an old Region 5 handbook. It was built in a time when we had timber management plans on the national forests, and these numbers were designed to provide for yields, forest product yields over time. The one that's in the number of trees per acre by site and by forest type, the numbers of trees in the recommended column those numbers of trees were about the right number that would yield, that would match the yields that were expected in the forest, in the timber management plan. And then the one over in the trees per acre values in the minimum tree per acre column, those are trees that would be acceptable, and the impact of having just that number of trees would be missing part of the expected yield in those plans. That was the full, that's it. That's the intent of this graph. I still don't think it's, I still don't think, or excuse me, I think it still has value to help characterize what a forest would look like, because we're, even when I came to the forest, to the Stanislaus in the late 1970s, there were plantings that looked like shrub fields with scattered trees in them. And I've seen plenty of places today that we're still struggling with trying to reestablish forests on, that were forests, they were, so one of the ways I've characterized it is, do we have forest trees with shrub development, or do we have shrub fields with scattered trees? And so this type of issue about how many trees you'd like to have is still an important one in this region, and it's one that we haven't really fully addressed yet. Okay, so I mentioned earlier about the patterns people take planting trees. I just wanted to, so this is some of the work that I did. No, that wasn't me planting though, but this is some of the work that I was responsible for when I was on the Stanislaus. So this was meant to be a 7 by 14 foot planting spacing. So what you see are two things. One, you see that the 714 is difficult to see at this scale. And also the way that tree planters interact with each other, you don't always get this type of rigid grid thing that people can be concerned about. So whether it's on purpose or whether you design specific planting specifications that tell people to wander around a little bit, there's no reason, I don't think there's any reason for us to be terribly concerned about whether we're talking about square or rectangular spacing anymore. We can make choices in our contracts to distribute the trees in ways that will make sense in the long run. I got a couple more examples here. Same type of an area. This one was actually, the next two will actually have been thinned before, pre-commercial thinned, and so you can see too. Now, not everything survived, and I think people understand this. This is just the way that things will happen. This next one here, I was especially interested in this one. When I first saw this watershed in the early 80s, I walked over the stream course without recognizing it was a stream course because it was buried in bear clover. But after the wildfire, things changed. Sunlight was provided. The small survivors, the survivors of a riparian vegetation type rebounded really well, and you can't just easily step over that creek in the summer anymore. So there's quite a bit of difference here in terms of response to the tremendous change that occurred here with the big stand replacement fire. And then also you see the way that the trees are arranged too by humans. All of this has been planted. Okay, so I'm bringing up a couple of things now here. So there will be two slides here. This is one of the first ones. This is something from 1929. This is pretty fascinating. I think this is the map that existed, the STEM map that was done then, showing trees that are all greater than 10 inches. And this is a pattern that people believe can offer resilience in the face of wildfire in the future. So you'll notice that there are several clumps of trees. There are some trees that stand as individuals, and then there's trees that are a variety of spacing and sizes that exist here. The colors represent different species, but the sizes are the projected tree crowns. And you can see that there's a lot of variation here. And so the reason I wanted to show this to you is, one, if you look at the image on the left, can you imagine, do you think you can culture a stand to get to the point where conditions are similar to that on the right? And I'm going to believe that there are. And one of the reasons I want want to say that is because the trees on the left-hand side are young forest trees. Choices are made. Selections can be made as to which trees stay and remove. Timber production remains a portion of our national forest goals. We will have the ability to remove trees, to create openings, to change the way that trees are arranged over time, to add new age cohorts to the area. I think so. This one and this next one here tell basically the same point, but in two different ways. So this is one where the color gradient that you see, for example, what looks to be almost like a stream course, that's the middle of a gap in between forest trees. And so here's another reconstruction that's meant to try to paint a picture of resilience in the future. Again, you'll notice individual trees, groups of trees, of various numbers of trees. And again, I think this is something that we can do. I don't think we need to shy away from planting 20 trees per acre or in a variety of patterns and then just letting whatever happens over time. I think what we can do is we can reestablish forest cover and design it over time as we culture the stand to meet these future objectives. That is, if the pictures on the right represent the type of structure and arrangement that help us survive wildfire and also meet wildlife habitat needs, then I think we can do it. Okay. So release is something that's pretty, this is one it's difficult to happen. This is one that's difficult to make happen sometimes because primarily costs. But bear in mind that it's complicated by two things really. One of them is the environment that we've created when we've salvaged or not salvaged or done something with the dead trees. And then our choices of how we'll manage competing vegetation. I touched earlier on the fact that we do know how to make choices on managing vegetation. We have an idea what we get out of it. We get more complete competing vegetation control means trees that have larger diameters and taller in height faster. Maybe that gives us an advantage to make sure that these next trees have half a chance to survive the next fire. Okay, here's a quick glimpse here now of our planting and release program. So, and again, these are staged in time differently. So, for example, the peak of planting in 2010, the release of those trees are probably some of those trees are probably being released in those bars represented by 2012 and maybe 2013. So it's just always this pattern of pacing them. A couple of slides here I wanted to show you. Now this one, I'm going to ask you to focus on the very lowest bar, the light blue one on the bottom. Those are ponderosa pine, and what you see there from 2007 to 2012, we see information about how many trees have survived. We're asked to create stake tree surveys, and how that's done is someone goes around and literally taps a stake into the ground along a line of trees of a certain species, and then after the end of the first growing season, and again after the end of the third growing season, you take a look and go find out how many of those trees have survived. So reading directly from this chart, we see that in 2012, the data that I had at the time said 68 trees, or 68% of the trees that were planted next to these stakes have survived. And you'll notice the range here. So we go from the lowest point there at 47 up to that 68. Now this is year one. So there's just a quick snapshot of what it looks like for that species in these particular sites, and they're all over the regions. They're not just one forest. So 47 to 68 in year one, and then we take a look at the bottom again, and we see this one after the third year, and we see values from 19 to there's the 48 there too. So 19 to 48 are values that we see here. The reason that the variation occurs is multifold. One of them is that these are different forests, these are different planting sites, and every ranger district has its own favorite approach to try to make sure the trees survive, and some are more effective than others. Some are faced with more demands and constraints. than others do. That publication I showed you earlier on the right, where I showed you the two pairs, the pair of publications, the one on the right by Phil McDonald and Gary Fidler, this is included within it. And this tells a story that should be well known in this region, is that woody shrubs have an important impact on the development of forested stands. And you can see that on the classifications of woody shrubs, that the one on top is the one that's labeled as no brush, has greater height than the trees that are living in a more competitive environment with heavier levels of shrubs. Now, even if you set aside the differences it might make to human needs for wood products, look at the type of tree that you have that you're going to, so in 1990, if you have a tree that's almost 25 feet tall compared to a tree that's something like 7 or 8 feet tall, what do you think the differences would be in terms of survival in a wildfire? So we've got to get a grip on this business of how to make sure that we take all this time and effort to plant these trees. We've got to make sure that they make it through many decades. One other thing I'd like to mention before I leave this slide is there was a study done on the cone fire up within the National Forest in the Blacks Mountain Experimental Forest, where Martin Ritchie took a look at, one of our PSW researchers, took a look at what happens with manual release. And manual release actually had a positive value. But here's the data for this. Now, this was a relatively poor, it's not a very productive site, and it's kind of a harsh environment. But the average height growth of a tree that wasn't being released was about 6 inches over the course of the measurement periods. And the height growth of a tree that was being released was 8 inches. So there was a 2-inch gain, a statistically significant gain in height growth when the trees received release from competition. There were two manual releases of scraping, cutting woody shrubs away, 5-foot radiuses, in order to gain that extra 2 inches. So, okay, so it's just one of many stories. The publication by Phil McDonald and Gary Fidler, it tells many more stories about competition and tree growth, as well as the whole plant community response to vegetation control and manipulation. Okay, finally, these are things I think about and worry about quite a bit. I think we have to make sure that the fuel environment that we ask these trees to live in is appropriate. I don't know how to solve all the problems about the right number of dead trees left over to meet a variety of needs, but we're going to make a shot at it. We're going to take a shot at it for sure. But we have to somehow find a way to make sure that the environment, the fuel environment that these trees live in, is favorable for their survival and for their rapid growth. And then also the seedling resources. We're working on a whole bunch of ways to make sure that we give them the room that they need, the site resources that they need, primarily water, soil moisture, in order for them to even thrive. These two things have to exist together. These young forests won't develop well unless we make sure that they give them a chance to survive the next wildfire. And then also, there's quite a bit of discussion and hesitancy about various planting arrangements and trees numbers. And I think we have to make some, I don't think we should do everything in the same place. I think there's important slope important slope differences, important aspect differences that we have to be aware of and we need to be aware of. But I think we would do best to make sure that we provide enough options for future changes and decisions, so that we have trees to manage with, to meet human needs, to meet carbon storage needs, to meet forest product needs, to meet wildlife habitat needs. I think this is really important. And then the other part of this that's not often considered is a long-term view. I'm sure others, but certainly foresters should have been trained long ago to think in terms of longer terms, decades and centuries. And I think this is really important as we make decisions today to think how are we creating an environment today that'll influence the growth and development in decades to come. Okay, and I guess I'm getting the message to wrap it up. So that's my last point. So thank you for your attention. I hope it was of some value to you.
Thanks, Joe. Let's see if we have any questions for you. We had one that's been generating a lot of interest in the chat box over here. Someone asking about where they could get rust-resistant sugar pine seedlings. And Tom Blush has been talking to them, and Terry Griffiths has been talking to them. I guess the issue A is getting the seed, and the issue B is growing the seedlings. So I don't know if you care to comment on that.
Well, at the risk of saying something that to go against what Thomas said, well, let me just say a couple things that I can say safely. You know, our nursery at Placerville is interested in as many agreements that we can make to expand production rates and customers at the nursery. We do have some constraints. We do have constraints on who we can sell seedlings to, but maybe Tom's addressed some of that already, because I know that's one of the things he and I have talked about. But whatever we can do to increase this program for the benefit of everybody, I think we certainly want to talk to people.
Okay, there's another question here that's more complex by Sarah. Do you want to cut that in there?
Is it the one that's on the screen right now?
Well, it says no. It's how would steepness of slope affect mechanical versus hand scalping, size of scalp, general success following scalping? Do you think steeper slopes need some specific treatment for success on a large scale, or is it more a small scale issue?
Well, when a person just talks about a scalp to create a planting spot, then to some degree it's not so important. But when people start scalping a 5-foot radius around an individual tree or a cluster of 3 or 4 or 5 trees, there's a lot of soil moved around. Some people have concerns about how much soil gets pushed around, and unfortunately I've seen that well, I'm not talking about widespread erosion, but there's been erosion around the planted tree, so that all that soil movement wasn't so favorable on some of those trees on steep slopes.
Yeah, one of the issues I thought about this is the scalping practice. Does scalping, a bare area around a seedling when you're still maintaining a shrub component within 5 feet, does that actually just create great habitats for rodents?
I'm not sure. Are you? Is the
question? I'm just thinking that the rodents, are living in the shrubs, and they come out of the shrubs into the barren area to feed on the seedlings. I mean, do you experience that?
Well, in places where there's a lot of grass, certainly we have a heck of a time getting lucky with sharing the site with pocket gophers sometimes. But I think in general the woody shrub environments, we haven't had much of a problem.
Okay, great. There's a few more questions here. I don't think we're going to have enough time for everybody. One I can address right away. David Kelly's asking if speakers could supply bibliographies of their talks. The talks will be posted, but references associated with the talks, perhaps you can give those to us, John and Joe, so
Absolutely.
This can be posted.
Absolutely, sure.
Okay, there's some other questions here. Mark Rosenberg is asking about the relationship between fungus and young and live plants between pines and manzanita, and I think he's probably referring to some of the work that was done in Southern Oregon on mycorrhizal relationships between manzanita and pine and Doug fir, actually, I think, on harsh sites. Is that something you wanted to comment on, Joe?
I bet you that relates to some of the craft project that was done years ago in Oregon, in Southern Oregon, on BLM land.
Yeah.
Yeah. Well,
Mike Amaranthus was Mike Amaranthus, as I recall, was the researcher on that, who was looking at the mycorrhizal associations between the successional shrubs, sort of facilitating the health and vigor and establishment of Doug fir. I don't know about pines.
Well, we're moving some fungal material from the Placerville Nursery out into the planting world as best we're able to, just fortuitously. And then in terms of site, we still have an awful lot of woody material out there to sustain fungal populations. I know we can't. And there's no slowing down the response of the other native vegetation to recolonize these reestablished vegetation out there. So I don't think we've got much of a problem so far. I don't think if it is a problem, it's one of the ones that's a little further down on the list.
There's a big, long question here from John Buckley, based on repeat transects of conifer stands along the edge of Yosemite. Natural historic stocking was much less dense and far more open than any of the typical reforestation sites planted on the Stanislaus.
Absolutely, because there's a big difference between some of this historic and reconstructed stand work compared to development of new stands that have been affected in these big patches in wildfire. So the point I tried to make is that if we create the template with options for the future, we can meet a lot of objectives, and that the end goal, the end range, the multi-decade, maybe century or after, as we move along in decadal steps, we'll get closer and closer and closer to these pictures of historical and reconstructed stand structures. Absolutely. There's fewer trees and arranged differently, and that's where I want us to go as we culture stands through the decades.
There's some other questions that Rich Walker, I think he posed one about genetics, and someone else here is Tom Blush is mentioning David Neal at UC Davis working on funding for a tree genome project. There's a whole bunch of questions here. We're not going to be able to address them all. I think what we should do is bin them and refer them to the presenters and try to get you guys to respond to them. Is that reasonable for John and Joe to respond to these questions? We'll sort them out for you and then send them off to you.